Hi everyone. I'm super glad that I'm with you today at GeeCON. It's my first time when I'm presenting something at conference, so wish me luck. And do me a favor and think about a situation when you need to make a really tough decision, design decision. And when I said tough, I mean it. When you feel that whatever you will choose, it will require some painful compromises. Or recall that moment when people from business came to you and said, we need that feature fast, of good quality, and cheap. Don't they know that such things belongs to the land of unicorns? You should show them the Cambridge dictionary, so they will know that trade-off it's a balancing of two opposite situations or qualities, both of which are desired. Both of which are desired. And that's the reason why every day we need to wrestle between scalability and architecture simplicity, consistency and availability, and reducing technical debt and delivering new features. This presentation is called The Art of Trade-off because, in my opinion, the skill of making cautious, good enough decisions at the right time is essence for a software engineer. Hi again, I'm Michał Gwarzynski, and today I will give you my examples of trade-off which I need to make when I was working on marketing automation system in Allegro as a software engineer. Currently, I'm engineering manager in technical platform. So, remember that you can ask questions on Slido. So, before we start, I need to introduce you to the topic of marketing automation. So, later on examples, conclusion, questions. So, imagine the situation that you added something to cart, coffee beans, but you receive a phone call and you forgot to finish a process. This is a standard situation for e-commerce shop, and the marketing automation tools can deal with that. So our specialist can prepare a scenario which will react on the event, adding to cart, wait several minutes, and later on send a notification with reminder. Yeah, that's a silly example because we need to take into consideration a lot of other stuff, such as user's actions. Maybe he eventually bought these items, or maybe he is still active on our platform and he just wants to add something extra to the cart. Which communication channel should we choose? Mail, push, or mobile push, or web push? Probably this one, which he agree and make a consent. And can we personalize content? Let's say send him a recommended items which fit well to his previous activities. There is a separated consent for that. And when we finally select the mobile push, what message what type of message we should send? Formal or informal one? Probably it's a good idea to prepare A/B test for that and check the result. Maybe the answers depends on the category of this user and based on his age, for example. Or maybe he is our loyal customer. So there is no need to bother him because he will buy it eventually. And maybe it's a time to prepare a dedicated campaign only for cold customers which visit us after ages. So now you know the basics, and you know that marketers can use our tool to design, no-code tool, to design various scenarios according to their expertise. So now we can go through use cases, my use cases. First one I called Greenfield. Let's go back to 2020 when our marketing automation system rely on the batch processing. Under the hood, we use Spark and the other big data technologies. But we were limited to historical data. We run scenarios at most several times a day. And business wants something more. They want to make a decision based on the near real-time events. And I was a member of a team who has been chosen to make it happen. Let's check key factors of the beginning of this project. So business want to have short time to market. They want to verify their hypothesis. They want to have proof of the value. But on the other hand, the scale will be large eventually. And there is a steep start. Because in order to build marketing automation scenario, we need a lot of components which need to be created. Also, our UI wasn't built in that way that it's easy to extend to the totally new module. So these two groups of factors are in the direct contradiction. So it means there is a lot of place for trade-offs. And we knew that business stakeholders are not eager to wait quarters to see the first results of their investment. And we want to build a trust with them. So we don't want to make unrealistic promises. So we decided to take advantage of two key things. First one, that we already have existing system, and second, our users of our system working with us at the same company. So we came with some pragmatic but a little bit crazy trade-off. So we introduced new building block into our old system, which was called Run Live Campaign. And when the records reached those blocks, they were transferred to events, sent via event bus, our event bus, and then enter our new shiny system. Thanks to that, we could limit number of building blocks which are required to prepare proper user selection, design the proper cohort, and we could enrich those events with data. And then the most very limited building blocks were added to the new system. Yeah, that approach required compromise from the business because we start with very simpler scenario at the beginning. Yeah, we need yet another compromise here, which was UI, which was absent at very beginning of the moment. And there were only fellow software engineer who was eager to transform natural language into configuration of a desired scenario. Now we have AI agents for that. Yeah. Yeah. So we cut a lot of corners. Let's take a look at the backend side. There are multiple technologies for streaming processing. Unfortunately, we didn't use any of them. So we don't know their limitations, quirks, and the system which we want to build should support very dynamic scenarios. So that wasn't the best choice to choose any of them. We knew reactive programming because we use it in one project, but I prefer to forget about that, forget about this experience. So at the end, we choose something very simple. Kotlin as a programming language, and MongoDB as our main database. Why? Because that was our bread and butter. We use it multiple times, make a lot of mistakes, and now we knew how to tweak it and get the best of it. And this choice gives us this predictable development, which was important at this particular moment. So there is also one question what should be answered. Where we will put our code. In Allegro, there are hundreds of microservices. So maybe we create at least few new ones. Yeah, for sure, we need independent deployment. You know that feeling when you release something on the production, but after a few minutes or hours, your change is rolled back because there is a bug in this release, and you need to wait extra time. We would like to deploy stuff on our own. Yes, but one microservice is enough? We don't know. Probably in this scale, the system will be large and different part of the system will have different attributes, different demands. There will be differ in traffic, SLA, response time, workload times, and probably we would like to scale them independently. But at this moment, the one service treated as modular monolith, it's enough. Because thanks to all those previous decisions, we have a time to focus on stuff which really matters at this particular moment. Prepare a design which will support future development, future growth of this product. Marketing automation is pretty general concept, so it's easy to predict how this project will gonna behave. But we are not fortune tellers, so we can always be wrong. So when we defined modules in our modular monolith, we can change it when we knew more about the project itself. And those modules were just code put to separated packages. And borders of those packages were protected by ArcUnit. So, after a few weeks, we hit production. Our solution was error-prone, cumbersome. There was a potential risk of a performance limitation, and pretty boring. But on the other hand, we get fast feedback, we had a solid design, and we use gradual approach, and that solution was predictable. Yeah. So in literature, this technique is called walking skeleton. When you're providing smallest possible end-to-end implementation of a system and then develop it further. And because we have a solid foundation, the other components could be done by multiple people or even multiple teams. So that's the first example. The second one, it's about evolution of one of core building blocks, aggregated decision based on the aggregated data. From business perspective, that component can help marketers to answer questions such as, did customer click on the push notification? Did he see offers from category X more than 10 times in the last week? Yeah, and from technical perspective, this module was pretty simple. We have event bus, and we will consume business events from event bus and store them in our database. And then the other module will query this database, this module. And this case, when we can duplicate data, it's yet another trade-off, which was accepted by organization by default. When we denormalize data, in order to have yet another flexibility, and put data in the way to read it in perform way. And but we need a context to define what are our goal at this particular moment. So we decide that our solution will support more than 1,000 writes per second, and that will be a stable workload, and it will be more than 100 reads per second, but those workloads will be bursting because we will get data from batch processing. So this is a consequence of our previous actions, but on the other hand, because we have this big data stack, our service needs to store only data for at most 2 weeks. And let's check if database can handle this workload. And because we use Mongo as our database, the writes will always need to hit primary node. But those spikes from batch processing can be spread across multiple nodes, because we can configure our driver that way to read from the nearest node. Yeah. But the question is how we should put our data into this database. The most naive approach is to store one document per event and have primary key for this event ID and the secondary compound key for customer ID and the accurate add. So we need that in order to eliminate amount of documents on the index level, and then the database will go to the disk and load and make the filtering on the remaining ones. And because our users can prepare different type of queries, there is no way to prepare better index, because every index came with the price and the writes are slower, and it's impossible to predict what user can ask for, what attributes of the document, other those two ones. Yeah, but on the other hand, maybe we should figure out something better and treat document as an aggregation for customer and one particular date. Maybe it will be more effective for those writes, those spikes. And this is a problem between scalability and architecture simplicity. But once again, we are not sure which way is better. But we knew that those two implementations can be done in less than 1 day. So let's behave like our colleague from marketing and done A/B tests. So we fastly release first version on the production, connect it to the event bus, write some silly tests in Gatling, and after a day or two, we notice error on this second approach because our documents fastly reach maximal possible size of 60 megabytes. Reality is that this limit is even lower, something around 1 megabyte, because when documents are too big, they are not fit into index and the performance drop. But we take a look at this first naive approach, and it was good enough. So this time we could have them both. Simplicity and architecture simplicity is the end of this chapter. The next chapter starts few months later, when slow response time has arrived, slowly. And let's check our context. Now there's thousands of writes per second and read per second. The workload looks the same, and we observe 99 percentile on the reads and writes. And that's strange, because it's Mongo. I know we accept that it can generate long writes, but slow writes, but reads. So that was a right moment, because those times slowly getting longer and longer, but we still have time. So we take a look on the slow query logs, and we notice that from the index perspective, it looks nice. We limited number of documents only to tens of it. And but at the same line, we notice something strange. This query from secondary node need to wait because of global lock on the secondary node. And this is how we discovered that Mongo in version 3.0 or X has blocking replication. So when database primarily replicate data to the secondaries, Mongo need to use global lock to make it happen. Yeah, Mongo, we have dedicated team which run Mongo in our cluster. So we came to them, and they said that sharding for Mongo, maybe it's not the best choice, but they have something better. And they show us Cassandra. So Cassandra is really nice database. It's designed in scalability in mind, and partitioning is first-class citizen. Every record, every table need to have a partition key and a clustering key for ordering reason. And but why this Cassandra can be that good at the heavy writes? Let's take a look. Under the hood, when Cassandra accepts insert or update or delete, writes this information to commit log. And later on, this information about this change is stored in mem table, which is stored in memory. And grows slowly, and when this buffer will reach limit, it's flashed to disk as a SS table. And when something goes wrong, meanwhile, after restart, the Cassandra can restore unsafe mem table from commit log. So we have multiple SS tables, which stand for sorted string table, and it's used for log structured merge trees. And there are a lot of stuff going on under the hood. And that's the reason why Cassandra is so efficient in writing. But but there is a catch. The reads looks completely different than in traditional normal database. Maybe not normal, but which I used before. Because there is no single place when the whole record is, but changes are stored into multiple SS tables. So in order to read it, the database engine need to went through multiple of them, and because they are sorted, it's easy or fast to get a proper value. Under the hood, Cassandra use Bloom filters, which is my favorite data structure, by the way, and use other useful techniques to make it sufficient, such as composition of already existing SS table. So we knew that the right model is more efficient, and we thought we knew the limitations of the reading model, but you cannot be sure until you check it. So, because we use hexagonal architecture at the beginning, we just introduce new implementation for Cassandra, and once again we deploy yet another variant on the production. But this time our system works on the production, so we make the same things as before, but this time it's called shadow deployment, because you're deploying new variant and you can transfer the copy of production traffic to it and use, for example, dual reads on the other side and check the results. And we knew after that, we were sure that Cassandra is better choice for us. Yeah, but the price was that we introduced the complexity, because now we need to know more about Cassandra, which is not a standard database. And because of Cassandra internal structure, we have huge data model limitation, because there is no such things like joins or secondary index. And when your query will change, it's better to create new table, because this is how you deal with Cassandra. But that choice was worth it. And after few weeks, same stuff has arrived, but this time was a little bit different, because writes were fine, but the higher percentile was slow. And this time we check several things, and we end up on BigQuery, and we check the distribution of our events distribution per user per day, and we notice that there are some outliers. And normally, for some specific event types, majority of users has several dozen, but the really late percentiles have thousands of records. And because our query worked that way, it need to go through a lot of events per user. Response time for those users is slow. So we need to deal with this problem, and we struggle between business capabilities and architecture simplicity, because this problem in big data is called data skew, which is uneven distribution across partition. And Twitter, as I remember, Twitter, in order to deal with that problem, need to implement a special logic for for celebrities which have a lot of followers. So separated logic only for those outliers from data skew. But do we need those outliers? Let's go back to beginning. Our system is designed to send notifications. If somebody it's that active, such as, for example, big merchant, which sell a lot of stuff on Allegro, should we send messages, notifications to them? Probably not. And we talk with business, and they agree to blacklist those users. And we prepare some mechanism to automatically detect our outliers, and they were free of marketing automation. That helped us a lot, because not only this particular part of system improved, but also other. And we skip millions of records per day. And that's the end of yet another chapter. The last one happens year or two after this one. And nobody could predict it, because it was a black swan. So trade-offs are made in different places in organization. And our database team knew that Mongo is most popular database, and amount of maintenance which Cassandra needs, it's large in comparison of amount of services which use Cassandra. So our company make a strategic trade-off, and we were invited to verify, to change database to something else, change Cassandra to something else. So we started from Mongo, moved to Cassandra, and at the end, we end up once again with Mongo. But you know what they say. You cannot enter the same river twice, because you are different and the river is different. And that was in our case. Because that situation happened after several Mongo releases, major ones, and they improved their replication logic a lot. We also has changed, because we had better disk for this kind of use case. And once again, we use shadow deployment and compare two solutions and tweak it through several weeks or months. We even use Spring Reactor, because this module, after all those years, became a separated microservice. So this overhead of Spring Reactor could be limited to only one microservice. Yeah. So now you can think that we run in circle. It's not true, because we just made the best decision at the time in context which we have. If we decide to stick with Mongo and try to make it more perform well, other stuff need to be delayed. So there is yet another organizational trade-off, because our organization decide to create platform teams which could help us. So yes, we need to switch from Cassandra to Mongo once again, but all those time they make Cassandra up and running. And because of platform team, we could fastly deploy our service on the production. We had our event bus, which is called Hermes, and it's open source. So our director one day decide to spend time and money and create a platform team. So we are almost at the end of this presentation. So let's finish it with some actionable advices. And yes, I know that my project is completely different than yours, but you can always focus on your context. And when I say context, I mean multi-dimensional context. What is most important for your business? You need to know the limitation of your system and how they suit to the project grow. For what kind of workloads you design your system and how it will change in the future. Yeah. So trade-offs are always painful, but you need to know your context to know what is worth to pay a price. And building partnership with business give you that option. You can tell them about your struggles, and maybe they change their requirements a little bit in order to get something better. And always extend your knowledge. You need to learn about stuff which you use on the daily basis and get better, but you should extend your horizons. And few techniques such as this walking skeleton, all the knowledge how Cassandra is working under hood, I read before I even had this project. And there were multiple cases in my career when I was inspired by, for example, some database solution, because databases are truly distributed systems. And the last one, you can be, be critical about that, because they design their solution in some context. So you need to compare their assumption with your assumptions. And the last thing, you can be expert in the field, but you are not a fortune teller. So you need to make reality checks often. So prepare scripts, write tests, and reach the production as often as you can. And if it's not possible in your case, figure out something which give you reality checks. So now we can go to questions. And if you want to work with us, with our scale, we have open positions. So, did you try PostgreSQL? So, no, because it's the transactions. We don't need transactions. And why did you choose Kotlin instead of Java? Because we can. Yeah, when I joined Allegro, the Kotlin was widely used in multiple services, so that was just a default choice. And I really like this, those semantic sugars, and this possibility to slowly introduce new Kotlin classes into projects. So that was the last question. Thank you for being here.